Hello everyone, this is Dr. C. Sonia, Assistant Professor in Chemistry, SMS College of Technology. Today in this session, we are going to see about liquid fuel petroleum and also how to manufacture synthetic petroleum. Petroleum or the crude oil is naturally occurring liquid fuel. It is dark brown or black colored viscous oil found deep in Earth's crust. The oil is usually floating over a brine solution and above the oil natural gas is present. Crude oil is a mixture of paraffinic, olefin and aromatic hydrocarbons with a small amount of organic compounds like nitrogen, oxygen and sulfur. Paraffinic base type crude oil, it contains saturated hydrocarbons from methane to C35H72 with a smaller amount of naphthenes and aromatics. Naphthenic or asphaltic base type crude oil, it contains cycloparaffins or naphthenes with a smaller amount of paraffins and aromatics. Mixer base type crude oil, it contains both paraffinic and asphaltic hydrocarbons. The crude oil is obtained from earth is a mixture of oil, water and unwanted impurities. The crude oil is subjected to fractional distillation. During fractional distillation, the crude oil is separated into various fractions. Refining of petroleum. The process involves removing impurities, separation the crude oil into various fractions. The fractions have different boiling points. So first we have to separate water by Cottrell's process. The crude oil from oil wells is an extremely stable emulsion of the oil and salt water. The crude oil is allowed to flow between two highly charged electrodes. Colloidal water droplets combine to form large drops in which is then separated out from the oil. Removal of harmful sulfur compounds. Sulfur compounds are removed by treating the crude oil with copper oxide. The copper sulfate formed is separated out by filtration. And the purified crude oil is heated to about 400 degrees centigrade in an iron retort. The oil gets vaporized. The hot vapors are then passed into the bottom of a fractionating column. The fractionating column is a tall cylindrical tower containing a number of horizontal stainless steel trays at the short distances. Each tray is provided with small chimney covered with a loose cap. So the fractionating column is represented as this. You can see there's the loose cap that is present and you have the different segments, the chimneys. So in different layers of the fractionation, different byproducts are obtained and the uncondensed gas is removed from the top. When the vapors of the oil go up in the fractionating column, they become cooler and get condensed at different trays. The fractions having higher boiling points condense at the lower trays. The fraction having the lower boiling points condense at the higher trays. The gasoline obtained by this fractional distillation is called the straight run gasoline. Various fractions obtained at different trays is given in the following table. So we can see over here uncondensed gas that is below 30 degrees centigrade the boiling range and the carbon atoms from C1 to C4 the uses has fuel under the name of the LPG. Okay, so this LPG you're all familiar about. We use it in day-to-day life for cooking purposes. And next is the petroleum ether. The boiling point ranges from 30 to 70 degrees centigrade and the range of carbon atom from C5 to C7 it's used as a solvent. Next, gasoline or petrol, it's from 40 to 120 degrees centigrade and the range of carbon is from C5 to C7. Fuel for IC engines. So you use it in your vehicles. Naphtha or solvent spirit, it's from 120 to 180 degrees centigrades and the carbon ranges from C9 to C10 as a solvent and for the dry cleaning agents. Next is the kerosene oil which you are familiar about. The boiling ranges from 180 to 50 degrees centigrade, and the range of the carbon is from C10 to C16. Fuels for the stoves and jet engines. And next is the diesel oil. Its boiling range from 250 to 320, and the range of carbon atoms from C15 to C18. Diesel engine fuels, it's used in that. Next is the heavy oil. Its boiling range from 320 to 400, and the ranges of carbon atoms from C17 to C30. It's used for fuels for the ships and for production of gasoline by cracking. Okay, we'll see the different uses of fractions that is obtained during this process. One is the lubricating oil. They're used as lubricants. Petroleum jelly or Vaseline. It's used in the medicine and cosmetics. Grease used as a lubricant. Paraffin wax used in candles, wood polishes. Pitch at above 400 degrees centigrade used for making roads, waterproof, roofing, etc. So we'll see about the manufacture of synthetic petrol. The gasoline obtained from the fractional crystallization of the crude petroleum oil is called the straight run gasoline, and the amount of straight run gasoline is not enough to meet the requirement of the present community. So, we are in need of finding out a method, that is, we are going to produce this petrol by the synthetic process. So, manufacture of synthetic petrol, coal contains about 4.5% hydrogen compared to about 18% in the petroleum. So, coal is a hydrogen deficient compound. When coal is heated with hydrogen to a high temperature under high pressure, it is converted into gasoline. The preparation of liquid fuels from the solid coal is called hydrogenation of coal or synthetic petrol. So, hydrogenation of coal in Burgess process, it's a direct method. So, finely powdered coal is made into a paste with a heavy oil and a catalyst powder. Catalyst used is tin or nickel oleate. The paste is pumped along with the hydrogen gas into the converter, where the paste is heated to 400 to 450 degrees centigrade. During this process, hydrogen combines with coal to form saturated higher hydrocarbons. The hydrocarbons undergo decomposition at higher temperature to yield mixture of lower hydrocarbons. The mixture is led to a condenser where the crude oil is obtained. The crude oil is then fractionated to yield gasoline, middle oil, and heavy gas. So this is the budget process. You have that is the lignite, that is dust, and the heavy oil paste, which is sent into the chamber compressor to the chamber, and you get the petrol. The middle oil is further hydrogenated in the vapor phase to yield more gasoline. The heavy oil is recycled for making paste with fresh coal dust. The yield of the gasoline is about 60% of the coal use. Purification of petrol or gasoline. So, gasoline has some undesirable impurities like unsaturated olefins, coloring matters, sulfur compounds. The unsaturated olefins get oxidized and polymerized, thereby causing gum and sludge formation on stirring. So, unsaturated olefins and the coloring matter are removed by using a absorbent like Fuller's earth. Sulfur containing petrol is known as a sour spirit. The process of desulfurization of petrol is called sweetening of petrol. So, thank you.